Before determining concentration or amount of herbicide to use for a given concentration, we must first determine the water volume in acre feet. But first, there's two measurements that we need to do this. We need the surface area, which we have just learned to do, and we need the average water depth. Now, in small ponds, depth should be measured across the pond in at least two directions, making sufficient measurements to adequately describe the pond's depth. In many lakes, depth will be uniform throughout a treatment area. However, plots should be checked for uniformity of depth, and if they are not uniform, average depth should be measured. Average depth is calculated by dividing the sum of all the measurements that we make by the number of measurements. Now acre feet is determined by multiplying the average depth times the surface area in acres, or the equation is acre feet equals average depth times the surface area in acres. Now we can calculate the amount of herbicide needed for a specified concentration by using the following equation. The herbicide needed in pounds active ingredient equals the parts per million times the number of acre feet in the treatment area times 2.7. The number 2.7 is a constant because 1 acre foot of water weighs 2,700,000 pounds. Or in other words, every 2.7 pounds of a substance, such as a herbicide, in 1 acre foot of water is equivalent to 1 part per million. One more calculation must be made. Since the amount of herbicide needed has been calculated for the active ingredient, the amount of formulation needed must be determined. For dry formulations, such as wettable powders, dry flowables, pellets, or granules, the amount of active ingredient is divided by the percent active ingredient of the herbicide expressed as a decimal. In other words, if the formulation is an 80% wettable powder, divide by 0.8. For liquid formulations, divide by the amount of herbicide per gallon to determine gallons of formulation to apply. Or, for example, for 4 pound per gallon emulsifiable concentrate, divide by 4. Now, let's look at an example. A farm pond is found to be 1.6 acres in surface area, and the following depths are measured. In direction 1, 2, 3, 4, 4, 4, 6, 6, 4, and 2 feet. And in another direction, 2, 4, 6, 6, 6, 6, 6, 4, and 2 feet. How much copper sulfate is needed to apply to the pond for algae control in order to have a final copper concentration of 0.5 parts per million if copper sulfate is 25% elemental copper? Okay, we know that the average depth equals the sum of the measurements divided by the number of measurements. So we calculate this, and we find that the average depth equals 4.3 feet. Acre feet equals the average depth times the surface area in acres, or in this example, the acre feet equals 4.3 feet times 1.6 acres, or 6.88 acres. The herbicide active ingredient equals the parts per million times the acre feet times 2.7. Or in this example, the herbicide active ingredient equals 0.5 times 6.88 times 2.7. So the herbicide active ingredient is 9.29 pounds of elemental copper. Since copper sulfate is 25% elemental copper, the pounds of copper sulfate needed is 9.29 divided by 0.25, or 37.15, or roughly 37 pounds of copper sulfate.